Hi, this is example number 5 from section 16.3. So we will learn here how to calculate velocities using relative coordinate system. In this problem, we have a rod, AB, that is rotating with angular velocity 60 radians per second. And we are asked to find the velocity of block C when the angle theta is 60 degrees and angle phi is 45 degrees. So as we see, having one angular velocity, everything is connected that make move the block C, so we can go from one side to the other and find the velocity. So as we see, the rod AB and the rod CD are connected in point B. So what I'm going to do is find the velocity of B using the rod AB, and then find the velocity of C using that velocity of B that I just found. So the first thing I'm going to do is find velocity of B respect to coordinate system attached to AB. So I have a absolute coordinate system xy, but I can imagine that I have one here, x prime, y prime, that is fixed to that rod AB. So using that coordinate system x prime, y prime fixed to the point A, and I can even say that fixed to the origin in the A fixed to the rod AB, I can say that the velocity of B will be the velocity of A plus angular velocity of AB, right? That is always in the direction is perpendicular to the plane of motion, which will be in K, cross product the vector position of B respect to A. So, and here we know that the velocity of A is 0 because we have a fixed point in A, so that will be angular velocity that is known, cross product. What is that vector of position of B respect to A? That will be that 300 millimeters, but if I want to put it in terms of X and Y, it will be 300 millimeters sine of 60, right? In negative, so it will be 0.3 sine of 60 in I, and in Y will be 300 millimeters, which is 0.3 meters, cosine of 60, plus 0.3 cosine of 60 in Y. The velocity of B would be, so the angular velocity is given, which is 60, and then I have to multiply K times I. You remember, I always use I, J, K. In this direction is a positive, and in this direction is negative, right? So K times I is J. So we have 60 times negative 0.3 sine of 60 in J, and then we have K times J is negative I, minus 60, 0.3 cosine of 60 in I. So if we calculate those, we know the cosine and the sine of 60, and we multiply, we get the velocity of B. The velocity of B, I'm going to put the result, will be negative 9I, negative 15.59 in J. And that's meters over second. So that's my velocity B. This velocity will be perpendicular to that rod, right? Which is not in the same direction of rod CB. Now, using another system, but now attached to BC, I'm going to put it in B, and I can call it X and Y prime. I'm going to calculate the velocity of C. And the velocity of C will be the velocity of B plus. Now the angular velocity is in the other system because I'm going to now use a reference system attached to BC. So I'm going to write here BC. and it's also in K. Cross product the position vector of C respect to B. And we don't have any relative velocity, so that will be, this velocity we know already, which is this vector that we just found. I'm going to write it first like that, and then I will substitute it because I want to do this product first. So this is an unknown, and this is K. And what is the vector RC? We are being asked to find the velocity of block C when phi is 45 degrees, and we know this dimension 600, so that will be 0.6. So what do I have in I? In I have 0.6 negative times sine of 45. And in Y will be also negative 0.6 cosine, this is in I, 45 degrees in J. So finally, I have that the velocity of C will be equals to the velocity of V. I will substitute that already. Will be negative 9 in I, negative 15.59 in J, plus velocity BC in K. So now I multiply K times I is J with this negative. It has a negative sign right here. So let me put a negative right here. 0.6 sine of 45. Oh, sine of 45 we know that is square root of 2 over 2. J, right? This is K times J is negative I. With this negative becomes a positive. Omega BC 0.6 square root of 2 over 2 in I. So, and the other thing that I know is the direction of velocity of C, because that block is forced to move within that guide. So I can actually, instead of putting that as a vector, I can say that this is velocity of C in J. So as you see, this is a vector equation that becomes two scalar equations. So let's write scalar equations. Right here, so in I have what? So 0 over here equals to negative 9 plus this one here plus omega BC. I have the number right here. I have that number already. I will write it down. 0.424. And in J, we have C equals 2, then I have this number, 15.59. This is 15.59. Let me fix that here, 59. 59 negative, and that number right here, which is 0.424 BC. So, and that gives me a system of two equations with two unknowns. And from the very first equation, I can get the value for the angular velocity of BC, which is 21.4 radians per second. And then I get the value for BC from this equation, negative 24.59 meters per second. So those are my both results from what I was looking for. So I was looking for the velocity of block C for a specific instant. And those are the results that I get.